Hello my dear students. In this video we are going to derive a very important derivation in class 12 physics, that is alternating voltage applied to a series LCR circuit, and we are doing this derivation exactly according to NCERT so that you will not lose any marks in the examination. Okay, AC voltage applied to a series LCR circuit. So we have a circuit wherein there is an inductor and there is a capacitor and there is a resistor, and these three are connected in series, and we have applied a alternating voltage. We have applied an AC voltage. So L, C and R, these are connected in series. Okay. And now we are going to do phasor diagram solution. Okay, we are going to do phasor diagram solution. Phasor diagram solution. See, in this derivation, drawing the diagram is very important. Drawing the diagram, drawing the phasor diagram and understanding the phasor diagram are very important. Okay, so what we will do, first we will draw the phasor diagram. Say this is the phasor of voltage across resistor. This is the phasor of voltage across resistor. Okay. And this is the phasor of current. Phasor of current. We know that in the case of resistive circuit, voltage across the resistor and the current, they are in phase. There is no phase difference. So therefore, they'll be parallel to each other. Okay. Now we know that in the case of pure inductor, in the case of inductive circuit, voltage leads current, correct na, by pi by 2. Voltage leads current by pi by 2. This is therefore phasor of voltage across inductor. This is phasor of voltage across inductor, because in the case of pure inductive circuit, voltage leads current by pi by 2. Okay. Now this is voltage across capacitor, because we know that in pure capacitive circuit, current leads voltage by pi by 2. Okay. Now, what is the resultant voltage? Okay, resultant voltage V is equal to VR, okay, VR plus VL plus VC, means we have to add them. So how to add them? First we will add these two. Okay, so here what we have taken, we have considered that VC is greater than VL. Okay, VC, voltage across capacitor, is greater than voltage across inductor. So it is a consideration. You can take reverse also, no problem. Now if you add these two, resultant of these two will come in this direction. Correct na? Because this is bigger, correct na? This is bigger. So what is this? This phasor is VC plus VL. Okay, this is VC plus VL. Okay, but how to find the magnitude? Magnitude, how to find? VC minus VL. Correct now. What is the length of this? Length of this is VC minus VL. Okay. Now this is, when you add VL and VC, you get this. And here there is a voltage phasor across resistor. How to find the resultant? How to find the resultant? Complete the parallelogram. Okay, so this is the resultant voltage. Okay, say resultant voltage makes an angle omega t. Phase of resultant voltage is omega t. Say the phase difference between current and voltage, phase difference between current and resultant voltage, say this is phi. Okay, now we know that length of the phasor will give you its peak value. Okay, length of the phasor means length of this phasor will give you its peak value. Okay. So therefore, what is the length of this? Okay, what is the length of this? VC minus VL, correct now? So length of this, okay, length of this, I'll just change the color. Length of this is equal to VCM minus VLM. So length of this is VCM minus VLM. What is length of this phasor? Length of this phasor is equal to VM, maximum value. Correct now? Because length of the phasor will give you its peak value. VM stands for maximum. Okay. Now what is length of this? Length of this is VRM. Correct. If length of this is VRM, length of this is also VRM. Okay. Now I'll name this triangle something like this is O, this is A, okay, this is B. Okay, so we have got a right angle triangle here. So in this right angle triangle, I can write OA square, okay, OA square is equal to BA square plus OB square, correct na? BA square plus OB square. I'll just change the color. Okay. OA square is equal to BA square plus OB square, because we have a right angle triangle here. Okay. What is OA square? OA square means VM square. VM square is equal to BA square. BA square means what? BA square. What is this? VRM whole square. VRM square plus what is OB square? What is OB? What is OB? This OB means VC minus VL. Correct na? VCM minus VLM whole square. VCM minus VLM whole square. Now, what is the equation for voltage across resistor? Maximum voltage across resistor is equal to maximum current into resistance. Correct na? Maximum current into resistance whole square. What is voltage equation? Voltage equal to I into R. What is the equation for maximum voltage? Maximum current into resistance. Correct na? Maximum current into resistance whole square plus what is voltage across capacitor? Voltage across capacitor is equal to current across capacitor into capacitive reactance. Current across capacitor into current capacitive reactance. What is its maximum value? How do you get maximum value? Maximum value is given by maximum current into capacitive reactance. Okay. Minus what is VL? VL means I into XL. What is its maximum value? IM into XL. Okay, whole square. Now what happens? I'll go to next. I can take this IM square common. Then what happens? VM square is equal to IM square into IM square into R square plus here also IM square I can take it outside, correct na? Plus okay, IM square I have taken it as common. IM square into R square is there, correct na? R square into R square plus okay, R square plus IM square I have taken outside, XC minus XL whole square. What happens? XC minus XL whole square. XC minus XL whole square. Now I'll write an equation for IM. IM square is equal to VM square divided by R square plus XC minus XL whole square. Now you may ask one question, why we are writing an equation for IM? Because in the derivations wherein alternating voltage is applied to resistor, capacitor or inductor, what we were doing, we were calculating the phase difference between current and voltage, correct now? So here the current value in the circuit, we have assumed it as I is equal to Im sin omega t, Im sin omega t plus phi. Okay, I is equal to Im sin omega t plus phi. Our derivation will be over if you find the value of Im and if you find the value of phase difference. If you remember, current voltage applied to resistor or inductor or capacitor, in all the three derivations we have found phase difference, correct now? Phase difference we have found. So here also, if you derive an equation for phase difference and if you derive an equation for Im, you get the equation of current. Okay, so here according to the diagram, equation of current is I is equal to Im into sin omega t plus phi. So what is phi? We don't know, we have to find out. So if you find this equation for phi and equation for Im, the derivation will be over. So therefore we are writing an equation for Im. So therefore what is Im? Im is equal to, taking square root, correct now? So Vm divided by square root of r square plus xc minus xl whole square, r square plus xc minus xl whole square. Now this is like I is equal to V by R, correct now? So therefore this is the effective opposition offered by the LCR circuit to the flow of AC. So therefore we call it as impedance. So this term, okay, so therefore impedance which is represented by capital letter Z is given by Z is equal to square root of r square plus xc minus xl whole square, r square plus xc minus xl whole square. Okay, now if you come back to the phasor diagram, okay, how to find out phi? See, this, if this angle is phi, this angle, okay, if this angle is phi, this angle is also phi, correct now? If I define tan phi means what? Opposite by adjacent. What is opposite side? VCM minus VLM divided by VRM, correct now? Tan phi is equal to OB divided by BA, okay, tan phi equal to tan phi is equal to OB divided by BA. So what is OB? OB equal to VCM minus VLM. VCM minus VLM divided by BA means VRM, correct now? Because in the equation I is equal to Im sin omega t plus phi, I have found Im. Now I have to find phi, phase difference. Okay. So what is VCM? VCM is equal to maximum value of voltage. Okay. Im into XC minus VLM means what? Im into XL divided by what is VRM? Im into R. Now you can take that Im common. So therefore tan phi is equal to Im into XC minus XL divided by Im into R. So that Im gets cancelled. So tan phi is equal to XC minus XL divided by R, or phi is equal to tan inverse of XC minus XL divided by R. So the derivation is over. We have found Im and we have found the phase difference. Now the derivation is over. One more thing that is given in NCERT, if you look at NCERT, they have given a diagram called impedance diagram. See, if you look at this equation, we can write a diagram like this. This is Z, this is R, and this is XC minus XL. Okay, this is a right angle triangle. See, now you Pythagoras theorem. Z square is equal to R square plus XC minus XL whole square. Correct now? Z square equal to R square plus XC minus XL whole square. Z equal to square root of R square plus XC minus XL whole square. This diagram is drawn using the formula of impedance. Therefore, we call this diagram as impedance diagram. If you look at this diagram and if you define tan phi, what is tan phi? Tan phi equal to xc minus xl, xc minus xl divided by r, or phi is equal to tan inverse of xc minus xl divided by r. So what we have done, we have written an equation for phi using impedance diagram. Okay, using impedance diagram also you can write, or using original diagram also you can derive equation for phi. So now the derivation is over. So here in this derivation you might have observed, this is the diagram. This diagram usually doesn't carry any mark, because we are deriving equation for current. We are deriving Im and phase difference using phasor diagram. Okay, so this diagram is very important. This diagram is very important. So this is the, I'll just revise, this is the phasor of voltage across resistor. In the case of resistor, voltage and current are in phase. Okay, then we know that voltage across inductor leads current by pi by 2. So therefore this is voltage across inductor. And in the case of capacitive circuit, current leads voltage by pi by 2. Okay, so then what we have done, we have added these two. Now we have done a consideration. What is the consideration? VC assumption, VC is greater than VL. If VC is greater than VL, resultant will be this. Okay, then we got a right angle triangle. So then what did we do? We applied Pythagoras theorem. Okay, we got one equation for Vm. Okay, then we got one equation for Im. So here, why we have derived equation for Im? So initially we have assumed that equation for current is I is equal to Im sin omega t plus phi. What is phi? Phi is the phase difference. In LCR circuit, what is the phase difference? We don't know. Therefore, if you find phase difference and if you find the equation for Im, the derivation will be over. So that is why we are calculating Im. Okay, and we got the equation for Im equal to Vm divided by some quantity. This quantity is analogous to resistance, or this is the effective opposition offered by the LCR circuit to the AC. This term we call it as impedance. Impedance equal to square root of r square plus xc minus xl whole square. Now using this derivation, using this equation, we wrote a diagram. We call this diagram as impedance diagram. What is this diagram? This is called impedance diagram. If you look at this impedance diagram, you can define tan phi. Tan phi equal to xc minus xl divided by r, or phi is equal to tan inverse of xc minus xl divided by r. Once you write the equation for Im and the equation for phase difference, the derivation will be over. Okay, hope you understood this derivation. Thank you very much.